G'day YouTube. Welcome back to the Kraken installation tutorial video. Apologies for the multiple day delay in getting part 2 recorded and uploaded. The rainbow tables writing process took longer than I anticipated. It was getting quite late into the evening, so once the behemoth.py script had finished doing its thing, I powered off the PC and went to bed. However, I did take a screenshot of the stopwatch timer before calling it a night. Using an SSD and a much more powerful PC compared to my old Kraken machine, it took a total of 4 hours and 53 minutes. Not bad at all in my opinion. So let's continue on with the tutorial. Let's just briefly recap what we did in part 1 of the Kraken installation tutorial. We downloaded and compiled the Kraken source code. We then initiated the rainbow tables writing process with behemoth.py. That took the DLT files stored on our source drive, in my case this hackerwarehouse.com external hard drive, and it wrote them in raw format to the destination drive, which in my case is this Samsung SSD. Now we will inspect the outcome of running behemoth.py to ensure that everything went according to plan. So if you haven't done so already, you can open up a file browser here and we can navigate to the indexes folder contained within the Kraken folder. Another way to view the contents of a said folder is to cd change directory into it and then type ls into the terminal and hit enter. So there are a couple of fundamental differences compared to before we initiated the behemoth.py script. We can see that there is a total of 40 files with the extension .idx. These files are the equivalent of an address to where the rainbow table is stored on the destination drive. And these files tell Kraken where to look when it needs to look up a value in a certain table. If we open up our tables.conf config file, we will also notice a change. The behemoth.py script has amended our config file with the offsets of each of the 40 rainbow tables on our destination drive. So everything is looking good so far. So without further hesitation, we can progress to the testing phase of the tutorial. In order to launch Kraken, so we can see if it is functioning correctly, we need to run a command to start the application and load the rainbow tables. So if you haven't done so already, you can open up a terminal window and run the following 3 commands. We cd into our home directory. We type cd kraken / Kraken with a capital K and hit enter. And the third command we write is sudo or superuser / because we are running a binary, 2 full stops / type indexes and then another / and hit enter. And you can see now that Kraken is loading the index files. And the application has launched successfully. So Kraken has a very simple command line interface. There are only 3 commands: crack, test, and quit. We could easily just type test and hit enter, but that's boring, right? Let's do something a bit more fun for our Kraken testing. Instead, let's crack a real A51 encrypted key stream extracted from a GSM base station, captured and uploaded by this individual on the gr-gsm GitHub page. I just want to point out that these encrypted GSM communications were uploaded by the owner of the data themselves for the purposes of testing gr-gsm's decoding features. And the link to the GSM capture file is here. The owner of the data also tells us the KC encryption key here, but I cracked this capture file on my own independently. So I'll just copy and paste the cracking command here. I'll definitely put it down there in the description so you guys can easily copy and paste it, because you do not want to transcribe a 114-bit string of zeros and ones, believe me. So yeah, we'll just paste that into Kraken's command line interface, and then we'll hit enter on that. I won't exactly explain how I obtained this key stream, because I've done videos on that subject in the past. I've done quite a number of GSM A51 cracking videos, which you can find on my channel, which will lead you, if you follow along with them, will lead you to obtaining this string so you can feed to Kraken. So after a little while, we should see a result displayed in the output of Kraken. So we'll just patiently wait. Should take around 88 seconds, roughly, I believe. A lot faster than the 2 minutes and 20 it used to take on my old machine. I think it's closer to about 1.5 minutes now, I believe. Thank you to the SSD. Faster reading and lookup speeds, I believe. Should be a lot faster than trying to perform millions of reads on a 5,400 RPM NAS drive anyway. Still not as fast as using GPUs. GPUs are far faster for doing cryptographic calculations. And here we go. Bingo. We can see that Kraken has found a candidate key, which is this part here, at bit position 48, which means 48 bits into this 114-bit string of binary ones and zeros. And it tells us the rainbow table in which the result was found. So that's very cool. Now, this output from Kraken is not the encryption key that was used to secure these GSM communications, and there is a reason for that. Castor Knoll, who was the founder of the A51 cracking project and led the development of Kraken and the generation of the A51 rainbow tables, said in his Black Hat 2010 presentation that the development team deliberately made Kraken difficult to use to keep it out of the hands of script kiddies like myself. So in order to actually find the KC value, which can be used to decrypt GSM traffic, we need to generate some input to feed to another program included with Kraken called find_KC. So we need to exit Kraken now by typing quit and hitting enter. And then we change into the Kraken utilities directory like so. We type cd space 2 full stops. And then we type cd utilities with a capital U and hit enter. So I've already generated this input to feed to find KC. So I'll just copy it and paste it into the terminal here. And I'll just briefly explain the contents of this command. So find KC is the name of the binary. We put a dot and a slash because we are initiating a binary via the command line. Oops, I think I just stuffed that up. I'll just repaste that quickly. Sorry about that. Okay, where were we? So we type dot slash find KC. We put a space. We put the candidate key here. We type the bit position. This is the guessed encrypted frame count. This is the previous guessed encrypted frame count. And this string of binary ones and zeros, 114 bit, is the previous frame burst XOR output. It's very confusing, but watch my other Kraken videos for a more in-depth explanation as to what all these numbers indicate. So finally, once we have typed out or copy and pasted our input to find KC, we'll hit enter. And bingo, find KC has found the matching encryption key that was used to secure the communication between the GSM base station and the mobile subscriber's phone. So yeah, we have a fully working Kraken setup now. So that is very, very cool. I'm pretty happy with the speed improvements using a more powerful PC and fast SSD storage. So I also have an old Radeon HD 6990 GPU from eBay coming. So I can attempt to build and run Kraken with the GPU support to further decrease cracking time. Because Kraken is quite dated at this point, only earlier AMD Radeon GPUs can work with it, and you need older versions of the AMD APP SDK and AMD Catalyst drivers. I might have tracked down old enough versions for these for a Ubuntu 12.04 bootable USB I am constructing. So watch this space for a video about A51 cracking on AMD GPUs 2010 style. And while we are on the topic of GPUs and cryptography, check out the Deca video I uploaded today. That's very cool. So I'll just finish this presentation by addressing a few things. I've been getting a lot of emails and comments on my channel asking if Kraken can crack A5/3 encryption, or if it is possible via some other method to crack A53. And the answer to that is a very, very hard no. You cannot do it. Kraken and its rainbow tables cannot ever be used for cracking A53. Nor can they be used for cracking A5/2 if that has ever even been seen in the wild before. I don't know. Another thing I'll address is the fact that I actually have no idea if A51 encryption is used on any cellular carriers' GSM networks anymore. From what I read online, telecommunication companies began deploying A53 encryption on their networks in response to the GSM Association amending the GSM technical standards to allow for stronger encryption in response to the A51 cracking project. Australia has no 2G or active 2G networks anymore, so I have no clue if Kraken will work on a modern 2G cellular network. I give GSM and GSM cracking a lot of attention on my channel because I have a hobbyist interest. I have a hobbyist level interest in cryptography. I have absolutely no intention to ever perform these attacks on a real cellular carrier's mobile network. If you want to try and crack real A51 encrypted communications, the best way to do that is to purchase a very, very old GSM telephone that was produced and sold before A53 was introduced into the technical GSM standards. And then you can send yourself a few SMS messages and call it from your other main smartphone and record the traffic with gr-gsm. Only ever record GSM communications originating from your own mobile phone and nobody else's. And with that being said, I'll finish with a very strong disclaimer. This video series was made for the purposes of education and experimentation only. IMSI-CATCHING, SMS-SNIFFING, and voice call interception on cellular networks is illegal and punishable by hefty fines and imprisonment. You have been warned. You're going to go to jail if you do this kind of stuff. If you value your freedom, do not reproduce the steps in my video. Only do it on your own communications or on communications in which people uploaded for the express purposes for testing GSM cracking and decoding. So yeah, that's about all I've got for you guys today regarding Kraken and its installation and testing. So I hope you guys enjoyed that. I'll catch you all later. Bye.